All right, this is example 2 of day 4 of our unit 3 of linear relations. And this is Larry, a former student of mine, for real, a grade 9 student from St. Peter's, went to the Peterborough exhibition in August. The Peterborough X charges an entry fee plus a set amount for each ticket, unfortunately. The recorded data relating the number of rides taken and the overall cost of taking those rides is represented in the graph below. Here we go. Examine the graph and answer the questions below. So this, again, is a very key day because we're going to go through some very important concepts of coming up with an equation for a linear relation. All right. So the first thing here is we're looking at is the value of the y-intercept. And what a y-intercept is talking about is the point in which your line here hits the y-axis. Well, we have a x-axis, and there's our y-axis. Just a little review of relations. And I look here, and here is the spot. Now, it's a little bit, because each block here, 2 blocks is 10. Each block is 5, and I think it's just above our line. And so the point in which our line strikes the y-axis, our y-intercept, I'm going to estimate and say that it is 6. Now, what does the y-intercept represent in this situation, right? Because now we're not just talking about equations, they actually mean something. Well, if I look over here on my x-axis, that represents 0 rides, but yet I'm paying $6. So what is the $6? Well, that must be if there's no rides, there is an entry fee of $6. So what does a y-intercept represent in this situation? Entry fee is $6. All right. Does our graph represent direct or partial variation, just like in my last video? Well, we look at where the point on the graph, the starting point of 0, 0, there it is right there in the blue dot. Does our line pass through that point? No, it does not. And so that means we are dealing with partial variation because it does not go through our point 0, 0, our origin. All right, now find the slope and explain what the slope represents in this situation. All right, so to find the slope, you need 2 points on your graph. And I'm going to use this point right here. Whoops, I'll use a different color. Let's go in green. To find my slope, I'll use this point right here. And I'll use this point right here. Now, again, to find the slope of the line, I'm looking for my rise, how much it goes up or down, and how much it goes right or left. And so if I'm finding the slope of my line, let's see here. So my rise is equal to, I go over to my graph. Let's see here. I believe that's 15. It's just above it at 16. It goes up to 26. So I believe it's gone up. And I'm going to include units here, 10. But looking on my y-axis for my units, because that's where I'm looking up and down, it's dollars. So the rise, it's gone up $10. All right. Now I have to divide that by the run. So I look at my run here. And let's see here. My run, how much I go left or right. Again, up and down, up and right are positive, left and down are negative numbers. So I start here, I go 2 blocks, but it isn't just 2 blocks. I go down here. That is moving from 5 rides over to 10 rides. So in fact, I've gone up 5 rides. Now, if I divide the rise divided by the run, and I account for the units, well, 10 divided by 5 is 2, but I'm going to have dollars per ride. So it's going to be $2. Whoops. $2 per ride. Oh, what is the slope? And sometimes these are obvious, sometimes they're not so obvious. Explain what the slope represents in this situation? Well, it costs $2 per ride. That's not too hard, is it? All right, now here we go. When we get to, we get to finding the equation. What's going on there? All right. Now, the equation of a line is always in the form y equals mx plus b. And the thing is that the two things we need to know is m, which is the slope, and b, and I don't know why they call them this, the y-intercept. All right, so we've already found this stuff. Our slope is $2, so that's our m value. Our y-intercept we found was 6, so that is our b value. All right, and so then when I'm writing the equation of a line, it's y equals, again, our m is the slope, so it's 2. We put an x there beside it because it's multiplying, and our y-intercept's a positive 6, so I'm going to put plus 6. And there's the equation of our line. Now that we have the equation of the line, we're going to use the equation of a line to find the cost of 40 rides. So again, I'm going to write down my equation of my line here. Y equals 2x plus 6. All right, now I have a 40 here. I need to figure out in this equation, is this 40 the y value or is it the x value? And here's how you tell. You use your graph. 40 rides. I go up to my graph. Hey, look at rides. That's on the x-axis. So the 40 is actually my x value. All right, and so what I'm going to do to solve this equation is I'm going to substitute in for my x value, which now I know is 40, plus my 6. All right, my y is equal to, well, 2 times 40. Again, I got to follow Bedman, so I'm doing multiplying first. 2 times 40 is 80, plus 6. All right, and which gives us a total of 86. Now, if we look up, what's the y value tell you? The cost. It's the money. So not only is this 86, put some units on it, we're talking about $86. Now, I could do the same thing with rides, but I'm going to move on down here, and I'm going to do G right here. Use the equation. And again, I'm going to write it down here. Y equals 2x plus 6. All right, to find out how many rides could be taken for $57. What is that $57? Again, I look back up at my graph. Dollars. That's on my y-axis. So that means this 57 is my y value. All right. So now to use the equation to solve, wherever there's a y, I'm going to substitute in a 57. So I got y equals 2x plus 6. So y is 57 is equal to 2x plus 6. All right. But again, solving equations, I got to get my numbers to one side, letters on the other. So I'm going to move this 6 to the other side. And when things change sides, they change sides. So I got a minus 6 is equal to 2x. All right. I'm going to simplify things. Well, 57 minus 6 is 51 equals 2x. All right. And then finally, to get my answer, again, I got to divide by the numerical coefficient, which in this case is 2, the number in front of the x. So I had to divide both sides by 2. And if I take 51 and I divide it by 2, I believe I'm getting 25.5. And we are looking for rides. So because the x does not take half tickets or partial tickets, it looks like we're only going to get 25 rides in, and we're going to get stuck with some extra tickets. But that's how many rides we could get for $57. All right, I'm going to make another video on the other example